Welcome to our channel Quaint Cosmos. Today's topic of discussion is a quantum phenomenon, and the name of the quantum phenomenon is the Stark effect. This effect was discovered in the year 1913 by Johannes Stark, and for his discovery he was awarded with Nobel Prize in Physics in the year 1919. Question is, what is the Stark effect? So what happens this effect is applicable for molecules and atoms. The Stark effect refers to the splitting or shifting of spectral lines when they are exposed to an external electric field. Okay, so you know spectral lines, you have the idea about spectral lines. So there is a shifting or splitting of spectral lines when the same molecules or atoms are exposed to an external electric field. That means an electric field is required for this analysis or to see this effect known as a Stark effect. Okay, so there are mainly two types of Stark effect: linear Stark effect and quadratic Stark effect. What is linear Stark effect? In case of linear Stark effect, the shifting or the shifting in energy levels of the atoms are proportional to the electric field strength. So this is linear Stark effect, and you can see linear Stark effect in case of simple atoms like hydrogen in excited states, hydrogen atoms in excited states. Again, there is a quadratic Stark effect. Here in this case, the shifting in energy level is proportional to the square of the electric field strength, And in case of complex atoms and molecules, you can find this effect, that is a quadratic Stark effect. And there are various applications of this thing. Actually, what is done? What is the use of this technology? By using electric field, by using external electric field, you are doing what? You are just splitting or shifting the spectral lines of the atoms and molecules. You are doing only that thing. But by analyzing those spectral lines, we can know many things about the structure of the atoms and molecules, and that is the actual use. So there are various uses. First use is the polarity of molecules can be known. The polarity of molecules. Next is the distribution of charge inside atoms. This thing also can be known. The distribution of charge inside atoms. Again, the map means I want to say that to map electric fields in plasmas and interstellar space, this technique can be used. Actually, this technique is used, to map electric fields in plasmas and interstellar space. And in modern times, it plays a crucial role in laser tuning and atomic clocks. Again, microwave spectroscopy of gases. For that case also, this technique is used. And one more use is there: high precision quantum state control in quantum computing. Quantum state control. So that is the requirement to a high accuracy that is required in case of quantum computing, and that is done by using this by applying this technique. Means which technique we are talking about? We are talking about the Stark effect. So many applications are there of Stark effect. It was discovered in the year 1913. So what is the time gap from now? More than 100 years. but still this is very important. When it was discovered, this effect proved the Bohr model, you know Bohr model of atomic structure. So it proved the Bohr model, but later it proved the quantum mechanics also. Okay, the same effect. And you know that spectral analysis or spectroscopic, spectroscopy itself is very important in modern times. In so many cases, this is used. That means we are still using the same old effect, which is more than 100 years old, the Stark effect. That means actually what happens since today's cutting edge technology, okay, in cutting edge technology this is being still used. In so many cases this is used. That means this has taken us to a new era. We can say this way, to a new era of science. Yes, that way we can say this. Anyway, so you can see that there are so many applications of this technique, this Stark effect. So no doubt this is very important. Anyway, so this is the end of this video. If you found this video fascinating, then please like, share and subscribe to our channel. And you can write in the comments below for the next video. And thanks for watching.